This discussion will cover clean rooms. Clean rooms are specially controlled environments where air particles are reduced to prevent contamination of products being produced. Clean rooms come in different levels of clean, which is a reflection of the number of particles per square foot or cubic meter. We will come back to this point shortly and compare the US and ISO standards in use today. In order to prevent airborne particles, HEPA filtration of air entering the room and gowning of individuals entering the room will be undertaken. Skin particles are shed during the normal activities of people moving about, and thus all skin will be covered and clothing will be covered with clean room attire as well. Contamination of products can come in a few forms. The non-viable particulates may be fibers or other small debris. Microbes often pose the greater risk because they will multiply under the right conditions and can ruin the product, or worse, cause illness in the consumer receiving the contaminated product. Common particulates include cellulose fiber from cotton clothing or plant materials used in the process, glass from broken vials, aluminum from the capping of vial process, and fibers from the PPE, as well as hair and skin cells. When producing a product, contamination may come from airborne sources or as particles formed in liquids or some sort of matter that doesn't belong in the final product. Clean rooms attempt to address the source of airborne contaminants. Microbial contamination poses a special risk since, when living, are capable of replicating in the product. The increase in number can pose health risks since organisms themselves may cause an infection, or their metabolic products might be toxic, or they might contain endotoxin in their cell structure. The most important or the most common microbial contaminants are bacteria that normally live on human skin, and mold spores, which are common in the air around us. This image is showing colorized microbes attached to skin cells. The table shows a few types of bacteria, often found as airborne contaminants, and where they came from. Staphylococci and micrococci are bacteria that normally live on human skin and thus are shed into the environment with skin cells. Bacillus is a common soil-dwelling bacterium and thus comes in with shoes and clothing. Humans are walking microbial communities. There are more microbial cells living on and in us than human cells. This table shows the relative concentration of microbes on various human locations. Nose secretions and saliva have immense concentrations, but the forehead, armpit, and scalp are also heavily colonized. Thus, moving around or merely talking, coughing, or sneezing will disperse microbes into the environment. Sneezing is a huge source of dispersal of respiratory droplets because they can travel up to 15 feet at 200 miles an hour. And keep in mind, those droplets are loaded with thousands of microbes per droplet. Some products must be produced in a clean environment to reduce the possibility of a contamination event. For example, products intended for injection must be produced under the most stringent conditions. An environmental monitoring program is required for the facilities, personnel, and the processes so that the final products are ensured to be safe, pure, and maintain effectiveness. The monitoring will include monitoring of the microbes and the non-living particles in the air. The environmental monitoring program will include HEPA filtration certification on a regular schedule, a clean room cleaning and disinfection program, qualification and requalification of the clean room by some oversight program, airflow pattern visualization, which is how they know where air currents are located, which is critical when working with open containers in the clean room. There must be standard operating procedures for work occurring in the clean room, and a training program for employees who will work in the cleanroom environment. Not everyone is cut out for this type of work. The clothing gear can be a bit constraining or claustrophobic for some. The extreme cleanliness required of hair, skin, and clothing can be undesirable or unsustainable for some people. And some people are found to naturally just be excessive shedders of particles. It's not their fault, it's just a matter of human variability, and those individuals are not well suited for this environment. In addition, you cannot just get out and take a bathroom break anytime. Entry and exit of the environment is not a simple matter, and transitions must be planned and deliberate to ensure sterility and productivity. This slide has a table which provides an overview of the categories of clean rooms. The U.S. federal standard provides a number. The value represents the maximum number of particles that are allowed in that environment. There are now ISO standards for clean rooms, 1 through 9. It's an international standard more commonly in use today. The lower the ISO designation, the more stringent the requirement for particulate reduction. This is detailed in the next slide, but here you can see this comparison of the federal standard with the new ISO designation. This slide shows the ISO standards for the clean room. ISO 9 is the least stringent and is probably like more normal manufacturing sites where particulates are not of great concern. The requirement is not too hard to achieve. Compare that to ISO 1, where the larger air particles are not allowed at all, and only very few of the very smallest particles of 0.1 micron are allowed, 0.2 microns, are allowed to be detected. This is almost pure air. There's very, very little else in that airspace. Critical components are made in such spaces. Let's look at the basic principles to monitoring a clean room. There are particle counters to measure any particle, viable and non-viable, and then there's the microbial contaminant monitoring. To monitor microbes, air samplers collect a predetermined amount of air and push that air against a dish of medium to grow microbes. This is called impact monitors for that reason. Resulting colonies of organisms are counted and reported per cubic meter of air. The class 100 and 1000, which is equivalent to ISO 2 and 3 clean rooms, are used for critical processing of products. There can't be more than 3 CFUs, 3 colonies that form after sampling a cubic meter of air. This sampling must occur during each shift in the clean room. In ISO 4, or class 10,000, the process isn't quite as critical and must be monitored each day and found to have less than 20 colonies form per cubic meter of sampled air. Less stringent even is the ISO 5 or class 100,000. These are usually support areas for the clean room produced products. In this space, it must be monitored twice a week. You need to find 100 colonies or less per cubic meter of air. The higher ISO clean rooms have even less stringent monitoring requirements. I hope this introduction to clean rooms is interesting and helps you understand a little about this manufacturing environment. Maybe you'll find yourself working in one in the future.